Uh, Good morning, everyone. So, very warm welcome in this class. Yesterday, we have discussed about algebra, some questions like quadratic equations, completing square method, factorization. So, yesterday, we have discussed that we will go for some topics. They are bearing, transformation, probability, statistics, and for tomorrow, get ready for a kind of small questions, a class test, right, on these topics. Okay, so we will discuss these topics that bearing you are confused, right? Nowadays, the bearing is very important because in earlier times also we are not that much dependent on the sea route, but nowadays the maximum trade among different countries from one continent to another continent is through sea, through ships, right? So the bearing is having a great application in your transportation or in the ships to locate the directions, okay, with respect to the position of the different ships, okay. In some emergency, any ship wants some help, so how he locates or how he gives his exact position in the very vast sea. Okay, so the bearing here plays a very important role to locate the position. So here, as we know, the four directions. For further, we are dividing the directions like north, south, east, west. Right? If one direction is north, it is south, east, west, right? And if we start clockwise or anti-clockwise, even further also we have divided these into four parts. And in this, so we have these eight directions. This is northeast, northeast, right? This is northwest, and this is southeast, and this is southwest. About the angles, if we start from if any object, when we are going, two ships are there. If one, this is the vast sea, and one ship is at point A and another is at point B, right? For any two objects, the north directions remains the same. The north direction remains the same. So what we are doing, we are considering that this is the north direction for from the ship A, and this is the, now what is the specialty for these two ships? If these are the directions towards north, these two directions, they are always the same direction. So these two kind of vectors, they are parallel to each other, right? So first we can have the attendance, right? So here we have Jasminder, good morning, bache. Puneet, good morning. Rest also, please, you can, once you are in the class, you should give your attendance. It should not be daily, okay, I should ask for the attendance even before the class. I was not able to connect due to some problem on exact 11:10. So 11:10 is class. You can come join 2-3 minutes before, and you can send me in the WhatsApp. Okay, sir, I'm right. So still only from Jaswinder side and Puneet. You have just sent the message. Good morning. So it is the kind of okay. You are attending the class. So attendance part is very important, right? So bearing, suppose here this distance, let this distance is in centimeters. Let this distance is here from A point to point B in centimeters, and this is 15 centimeter. It may be there that 1 centimeter scale, in actual it may be 1 kilometer or 1 mile, right? So here is not, if we are saying the bearing, and that this angle is like in book we have given one example saying this angle here is 135. So we are saying the bearing of B, what we say is the bearing of B, the bearing of shift B from A is 135 degree. Means when we start from A, from the north directions towards the B, okay, the angle that is 135. So as we know the complete angle that is 360, if here north direction we are going for 0, then this angle is what? This angle is 90 degrees, then one more 90 here, this is 180, again this is 270, and this complete angle is 360, 0 is with again 360, right? This is again 360, so here he is saying 80 plus 135, that is the back bearing, right? That is the back, the bearing of A from B. Puneet, you are asking, that is, if you are going for this one, let here, this is now the straight line, then this angle, alternate angles. This angle is again 135 degree. This is the confusion you are having. Now if my statement is the bearing of A from B, from B, that is the bearing, that is this angle is, this here is B, this is north direction, here also it is the north direction, right? And both are parallel to each other. So here from B, we are going 180 degree, okay, plus 135. These are two different things. One is the bearing of B from A, that is 135, right? Bearing of B from A, that is 135, and if the bearing of A from B, the bearing of the, that these are the two sheets, the bearing of A from B is that it is 513. This is the concept, the bearing of A from B is, so you are right now, but I don't know why people are not sending the attendance. Presently we have few more students in the class, but you are not sending the attendance. I have a right that, okay, For even new students, like they are also always giving their attendance on WhatsApp. So you are wasting the time. Even if you have some problem with the mobile or something, in beginning before the class you can send your attendance. Okay. Teacher should be aware that how many students or who all are attending the class. Why it is important? Because you are already very less in number. 10i, a very small class, and then also if I am not able to know how many students are my regularly attending my class, so that connect we cannot make, right? So tomorrow you can revise both these sine rule and cosine rule, how to apply, because most of the questions of bearing, if we have one shift A, right, from A, one is B, right, then the distance is given between A and B, right, and then if there is one more shift C here. Sometimes this BC direction is given. For bearing, we know the directions. We will start with the A, B and C with the north directions, and these all are parallel to each other, right? And with the help of bearing. Now it is very important that bearing of B from A, right? We are moving towards, that is in the clockwise direction, right? We are moving here in clockwise direction. Here also we are moving in clockwise directions. So if you want to have beam, that is always in this direction. If point B, we will go with from A this way, and from to C we will in this direction, right? From C, if we want to go for A, that is from here, or that is simple here, not that is already, this is the north here. And we will go for sine rule and cosine rule. Sine rule, and cosine rule. If we have one angle given and the length of the sides, then we can use the sine rule and cosine rule. If we have a triangle, in a triangle we have one side is A, this point is B and C. Let the distance here is A units, this distance is B units, and this distance is C units. So sine rule says that we have that sine of A upon A is equal to sine of B upon B is equal to sine of C upon C. Or you can write in this way that A upon sine of A, this distance A upon sine of A. If these angles are given, any of them, that is equal to B upon sine of B is equal to C upon sine of C. Whereas the cosine rule for these lengths A, B, C, if you want to find the length A, then what we are writing, that A square is equal to B square plus C square, B square plus C square minus 2BC cosine of A, right? That is B square plus C square minus 2BC into sine of, not sine is cosine of, that is A, right? So you can use the calculator to find these angles, sine as well as cosine, and substituting the value. Tomorrow I will have a small good questions based on these. So bearing is with your directions. We have discussed that bearing B from A, the bearing of B from A, that is 135, and if you are saying bearing of A from B, that is 180 plus 135, that is 315, right? Now, in transformation, don't go for your past papers, because from this year onwards, your matrices, that is not in your syllabus. So the whole application of the matrices, only you have to go for the vectors, the matrices, and there was the concept of adjoint, right? That is not in your syllabus. Transformation, we have the four things. One is your rotation, reflection, translation, and then the enlargement, right? Transformation, when there is a change, if some object is there, if we are sliding that object, so for this year, your transformation, we have one rotation. Like Puneet, you are asking, sir, how we are going. I will explain today how to go when we are rotating, how the shape will rotate. I was talking about the page, the trace paper we can use. I will give you here, or I will discuss. If we have a shape, suppose here is the graph. These are your x-axis, y-axis, y dash, x dash, and these are all quadrants 1, 2, 3 position. I am simply interested here. Let's suppose here we have one triangle, right? Let the triangle is 90, B is the 90 here, and A is here, and C is here. Now after rotating the triangle with particular angle, what will be the position? If I am rotating the angle in clockwise direction, rotation can be clockwise, either in clockwise direction or anti-clockwise, right? Now if I want to rotate it anti-clockwise 90 degree, how? If these are the vertices A, B, C, one is X, X1, Y1, X1, Y1, here is X2, Y2, and here is X3, Y3. These are the coordinates. Now after going for the rotation of 90 degree anti-clockwise, right? This triangle is in the second quadrant. When we are going the rotation 90 degree, so it will come in the third quadrant. And if we are going the rotation in clockwise direction, then from second we go to the first quadrant. So what we will do? We will put one trace paper, right? I have one here. This is although a napkin. I will fix the napkin here on this page, and I will locate here. I will fix the page here at the center, and on the page I will draw the triangle, right? If this is the triangle here, although this is the smaller one, so I will draw the triangle here, that is ABC. Okay, this is the triangle ABC here. I am able to see this is A with respect to origin, right here. This is A here, this point is B here, and this point is C. A, I am not able to write, but I have just pointed the 3 points. One is point A, one is point B, and one is point C. Now what I will do, I will fix the origin, and after origin when I will rotate it, this point A, it will shift simultaneously, and we will measure these points coordinates very easily. Just have a look. If I am doing in this way, I have a triangle here. Let me do it for you. That this is a triangle here. Now what I am doing, I am fixing this center point origin, and I am not changing the origin. I am just rotating it. So how it is going? It is going the rotation anti-clockwise. C points remains here. C points remains here. B is coming here, and A is going downwards. Right? This is what I want to convey here. So after 90-degree rotation, the figure will be in this way. Okay? A is going here, B is coming here, and C is coming here. And the distance, the C coordinates, they will remain same. This distance and this distance, that is, these two distances will remain same. This will be C dash. Similarly, the distance BC, this distance and this distance will remain the same. This is B dash, and here we have the distance AC, and this is AC and AB. So after going for the rotation of 90-degree anti-clockwise, we have the new triangle, that is A dash, B dash, C dash, and these are the positions, or these are the vertices of this triangle. Okay, so in this way you can go for the transformation. We have then, that is, one is rotation and one is what? Translation. Reflection. Reflection is very easy, you know very well, but still, if we have, suppose this is the triangle, if we want to go with x-axis, x-axis are behaving like a mirror, then C point is lying where? Here, same distance, but B point will come here, same distance here, and the C point, the distance of the A point, same A point will go here. This is the reflection of, this is the A dash, B dash, C dash, right? In another way, if a point is here, any point, so its perpendicular distance, if a point P is here, its reflection will be a perpendicular in opposite direction, that is P dash, right? If any point is here, Q point, so it is lying in the first quadrant, so same distance below, we will have its mirror image, that is your reflection. In the first case we have discussed rotation, now we are talking about reflection, that is reflection. Now reflection again, this is with respect to x-axis. Now with respect to y-axis, the concept will change. If y-axis behaves as a mirror, this is our y-axis. If y-axis behaves as a mirror, then the reflection of this ABC triangle will be this side, and this point P, its reflection will be now this side. It is same in the second quadrant. So P reflection will be here, P dash will be here, Q dash will be same distance this side, that is Q dash here, right? And if we have a triangle, this ABC, its reflection will be here. We have this point C, so same distance. This point will be C, right? This point here, same distance towards that side. We have this point B, and same distance this side. We have a point, that is point A, right? That is the point A here. Now, these are the reflections. So we'll write C dash, B dash, and A dash, right? Now, the next one is translation. Translation. Translation means when there is a sliding movement. Suppose this duster is the triangle here. Now I am shifting it towards that side. I am shifting it here. So how much it go for translation? First one we have discussed with you, rotation, reflection. Then the third one is translation. Right? And the fourth one, that is about enlargement. Means like the scale factor, like we are plotting on the graph, two ships on the page, the distance like in two ships was 15 centimeter, but in actual the distance is 15 miles. So that is what the enlargement, right? Here we will, in enlargement we will discuss like the similar things, similarity, scale factor. In translation we should be skilled with the vectors. Okay, how particular point from. So in vectors you know how to represent the vectors. Okay, the vector is from one point from A to B. So the translation is about the sliding movement. Translation is about the sliding movement of the object. From one point to another, right? In enlargement, we have the scale factor. How many times? Double, triple, 4 times, 10 times, or 100 times, right? So tomorrow I will give you some of the questions. So get ready, prepare with the concept of your both bearing and transformation. Especially now in your syllabus, these 4 concepts are there. That one is rotation, reflection, and that is enlargement and translation. Now if for reflection, if the object is lying on the axis, then where the mirror image or where the reflection will be? Suppose if y-axis, this triangle, it lies on the y-axis. Suppose here we have a triangle, one point is A, one point is B, and one point is C here. This is a triangle ABC. How to go for its reflection? So the point A and A dash, this is the point A dash will remain same. B dash will remain same. Only the C point, the point C will change. The same distance this side, perpendicular distance. This is always a perpendicular distance. So here this is C dash, and here we have the figure, that is the This is a triangle ABC and this is its the reflection, right? When this object is lying on the y-axis. If x-axis is the mirror image, right? If this is y is not the mirror, x is the mirror image, x behaves like a mirror. In that case, same if the object is in this shape, suppose you have the object that is A, B, this point is B, this point is C. So how the image is formed or how to find its reflection? Its reflection will be in the above quadrant. B dash remains same, C dash remains same. Okay. Now A here, we will find this perpendicular distance here on x axis. Same distance I will go here, that is A dash, and I will join this A with B and A with C, and this is the object here, right? So this will be its reflection. A, B, C, and A dash, B dash, C dash, right? Now a little about probability. Probability, I have discussed some of the very basic concepts about coins, right? When one coin is tossed, when two coins are tossed, three coins are tossed simultaneously, or even statement is when three coins are tossed, or I am saying one coin is tossed three times, that is one and same thing. So what is the sample space? That is about probability always lies between 0 and 1. If probability of an object, that is probability of an object is 0, then we are saying that is the impossible event. So always the probability of an event A is always less than 1 and greater than 0, right? Now we have, in very basic terms, we have two kinds of this approach. One is the theoretical approach and another is the classical approach. What is that theoretical and classical approach? Right? That is the empirical way. See, if one we are saying if a coin is tossed, what can come? We cannot predict. Right? If we are coin is tossed, head can come, tail can come. If one coin is tossed, this is the main statement of probability. Right? If one coin is tossed, it can, when one coin is tossed, head can come or tail can come, right? Even if I am tossing a coin 5 times, it may be there that head can come. Yes, it can come, even 10 times. But even 11, then maybe it's not sure the next time the head can come. So it is all about uncertainty, right? It is all about uncertainty. Probability is all about uncertainty. Even the probability we are saying is the game of chances, right? So we are saying the probability of this event A or probability of coming head, that is sample space is 2 and head is 1 by 2, and probability of the tail is what? Again 1 by 2, half of 50-50. 50-50. So here, this is what the concept. We are not performing the activity. If we are throwing a coin 10 times And if I am A, you are B and C, three students. If I am throwing a coin, maybe there seven times head is coming and three times tail is coming. If any one of you are doing, it may be there that four times head and six times tail. There may be some students who are getting 50 means 5 times head, 5 times tail. Or even one may get 2 times head and 8 times tail. Or even it may be there that all 10 times one is getting head. So anything can happen. We cannot say anything. But what is the probability? So in this case, what was the probability? If one is getting 7 times head is 7 times and tail 3 times. So the probability of coming head, it was 10. Total sample space is 10. So 7 by 10, that is 0.7. And what is the probability of tail? That is 0.3. So probability of head is greater than the probability of tail in this case, first case. Whereas in this case, head is less and this is our probability of head, that is 0.2, 0.2. If we are tossing the coin, that is 100 times, the same way we will go for total sample space, right? Now I am going for when 2 coins are tossed. Now if 2 coins are tossed, so please note down, if 2 coins are tossed, or the statement will be one coin is tossed twice. One coin is tossed twice. In these both cases, statement is same. We have the sample space, 4 as a sample space. We can get either head, right? We can take head tail head, or tail, right? So what is the sample space? Head tail head, or tail head. Now it is asked, what is the probability of getting both the heads? Both the heads, we have only one. The probability of event A is always equal to sample space is 4 and head is only 1. If they are asking what is the probability of this head, what is the probability of coming minimum one head? Sometimes the word are used at most, at least. These are the particular word used. One is at most, at least. So if I am asking what is the probability that at least one heads come. Now the condition is only on one head. Okay. Maximum it can be. So here the probability of the B, event B is one head is here, one head is here, and one head is also here. So that is 3 by 4, right? Same for the 3 coins. If we have the 3 coins and 3 coins are tossed, 3 coins are tossed, or one coin is tossed thrice, right? So what we have the sample space? We have 8 as a sample space, right? We have 8 as a sample space. So we have like head. We have head, tail. We can have head, tail, or head, tail. On the same grounds, we have tail. It means on all the throws we can have tail. or we can have tail on first two toes and then head, tail on first, head, tail, and then is tail, head, tail. So these are 8 events, the 8 possible ways in which this experiment can happen. Okay, this experiment can happen on all possible outcomes, or we can say this is the sample space. Now say my question is, what is the probability of coming at most 2 tails, or at least 1 tail? Probability of at least 1 tail. List means no in tail, 1 tail is here, 1 tail is here. So here we have the probability of the event C is equal to 7/8. Except this head, all these favorable outcomes we have these 7 tail is there, right? So that we have the very important example now of dice. When dice is thrown, we have 6 faces, and question is generally asked about the numbers, prime number. What is the probability of coming prime numbers? What is the probability of coming odd numbers? So we know in case of dice, and then we have playing cards. So you should have the knowledge of playing cards, right? Or I will try in some class, maybe I have shown you the cards. You should know the all colors and all, you can say 52 cards. We are saying pack of cards. So for dice first, dice is having 6 faces, and on all these 6 faces we have some numbers like 1, 2 and so on. 1, right? 2, so 3, 4, whatever points may be here, right? And on the back side, or even on, we have 1, 2, 3, 4, 5, 6. On first face 1 is there, 2 is there, 3, 4, 5 and 6. The question is there, what if a dice is thrown once, what is the probability of coming a prime number? What is the probability of coming a even number? What is the probability of coming a prime number? What is the probability of coming a composite mode? Any question can be of any type. Like for even, for prime, if you don't know how many numbers are prime, then it will answer will be wrong. So here prime numbers from first 6, 2, 3 and 5, they are prime numbers. So probability of the prime numbers is always here, that is 3/6. That is half. Now question is, when a dice is thrown twice or 2 dice are thrown, then the sample space will change. When the dice is thrown twice, or 2 die are thrown. ठीक है, या तो बेटा एक ही डाइस को 2 बार फेंकें, या दो, if we are throwing 2 dice together, sample space will be 36. We will get on the 1-1 poster, first पे 1-1, 1-2, 1-3, 1-4, 1-5, 1-6 आ जाएगा. On first, like 1 dice I am throwing in, 1 you are throwing. Suppose I am throwing, I am getting 1, and you are throwing, you are also getting 1. It may be possible that in your case 2 may come, 3 may come, 4 may come. If I am throwing, I am getting 1 and you are getting 6. So all possibilities can be there. Similarly, for me 2 can come, 3 can come, 4 can come, 5 can come, and 6 can come. For it, 2 2, 2 3, 2 4, 2 5, 2 6. Same. Right? 4 2, 4 3, 4 4, 4 5, 4 6. Same 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. And here we have 6 2, 6 3, 6 4, 6 5, and 6 6. Getting? So here we will find the total sample space, that is 36. Now if it is asked what is the probability that the same number appears on both the dice. What is the probability that the same number appears on both the dice? So you see, for this we have the only these cases that we have the same number. Probability of an event is total sample space is 36. So we have 1 by 6 probability. Here question is, this is very important question. They may ask what is the probability that sum of the two numbers is less than 3, or sum of the number is greater than 3, or what is the probability that sum of the number is greater than or equal to 3. So maximum sum here is 12. Here 1 2, that is 3, 2 1 3, that is 4 5 6 7, so on. So here you should know a few words, few terminology, right? So we will discuss in detail and the questions. Now we are starting these topics: varying, transformation, probability, statistics, and sets. So we will discuss these in detail. Okay. I will bring you some questions. Same is for the cards, playing cards. For playing cards, we are saying deck of cards or pack of cards. Deck of cards, or we are saying pack of cards. Every deck of cards consists of 52 cards. Among these 52 cards, half of the cards they are of black color. They are of black color and half of them are of red color. Means 26 are of red color and 26 are of black color. Out of these, we have 13 cards of different suits, right? Suits, like their dresses. So here 13 cards different, 13 cards different. The black card 13, these are called spade, and these 13 they are called your club. Here these are called heart, and these red are called diamond. So 13, 13, 13, 13 fours are 52. We have 13 of each suit and total 52 cards. Now we have a card number from 1 to 13. In every suit we have the cards from 1 to 13. 1 to 13, right? In every suit we have the cards from 1 to 13. You will find the shades black color here, spades, they will be of this color, right? They are black in color. The club here, club is of this sign, right? Whereas heart, you know red color, and here diamond, that is in Punjabi we are saying hukam, chidi, pan, they eat. Right? Now we have some face cards. We have three cards, that is Jack, what is also known as knave. Right? Jack or knave, that is 11, queen and king. We have this, we have 4J, Jack of spade, Jack of club, Jack of heart and Jack of diamond. Four cards Jack, 4 queens and 4 kings. These cards are called your face card. Why these are called face card? Because when you will see the cards, their faces are there. When you, this is the playing card, suppose if it is 2, so 2 is very simple, you will find this is in this way, that this is 2, and you will find out the shape of the card. Suppose I am talking about the club, but when it is about J, there you will find that the shape of the king, right? They will write J here or in this way, right? So the face on these cards, the king, queen or the jet, their face is drawn, right? So tomorrow get ready with these topics, these chapters, and please attendance is mandatory. Tell your other friends also. Now this is a very right time, okay? Otherwise it is very, you can say, I have about more than half of the class. If I am talking about the strength, now also more than half of the class you are watching me. So I have only the attendance from 2 students, Puneet and Jaswinder. Both, God bless you. Other also, please try to communicate. Even after the lesson, you can provide me the attendance. Thank you very much. God bless you. Have a good day.